Hello everyone, and welcome back to the channel. Have you ever wondered how our planet stays warm enough for us to live on? It's not just about being the right distance from the sun. There's a fascinating, invisible process happening all around us, every single day. It's called the greenhouse effect, and today, we're going to break it down. What is it? How does it work? And why is everyone talking about it? Stick around, because by the end of this video, you'll understand this crucial planetary system like never before. First things first, let's get the name straight. Why greenhouse? Well, think about an actual greenhouse that people use to grow plants. It's made of glass or plastic. Sunlight shines in, warming up the air, the plants, and the soil inside. The glass then traps a lot of that heat, preventing it from escaping. This keeps the inside of the greenhouse much warmer than the outside, even on a chilly day. Our planet has a similar, but much more complex system. Instead of glass, we have our atmosphere. So, here's the basic process. It all starts with the sun. The sun sends out enormous amounts of energy in the form of sunlight, which travels through space and reaches Earth. This sunlight is made up of different types of radiation. Some of it, like ultraviolet radiation, is mostly blocked by our ozone layer, which is a story for another day. But a lot of it, particularly visible light, passes right through our atmosphere and hits the Earth's surface, the land, the oceans, and the ice caps. When this solar energy hits the surface, it gets absorbed. The ground warms up, the oceans warm up, everything warms up. Now, anything that has warmth radiates heat. This is a fundamental principle of physics. So, the warmed-up Earth starts radiating its own energy back out towards space. But here's the crucial part. The energy the Earth radiates is different from the energy it received. It's in the form of infrared radiation, which we can't see, but we can feel as heat. This is where our atmosphere's greenhouse role really kicks in. While the atmosphere is pretty transparent to incoming sunlight, it's not so transparent to the outgoing infrared radiation. Certain gases in the atmosphere, which we call greenhouse gases, are exceptionally good at absorbing this outgoing heat. Think of them like a cozy blanket wrapped around the Earth. These gases include water vapor, carbon dioxide, methane, and nitrous oxide. Once these greenhouse gas molecules absorb the infrared energy, they don't just hold on to it. They re-radiate it in all directions. Some of it goes out into space, but a significant portion gets sent back down towards the Earth's surface. This re-radiated heat further warms the surface and the lower atmosphere. It has a continuous cycle of absorbing and re-radiating heat that keeps our planet's average temperature at a comfortable 15 degrees Celsius, or about 59 degrees Fahrenheit. Without this natural greenhouse effect, scientists estimate that the average temperature on Earth would be a frigid minus 18 degrees Celsius, or about 0 degrees Fahrenheit. That's freezing. Life as we know it simply couldn't exist. The oceans would be frozen solid, and the planet would be an icy, barren wasteland. So, the natural greenhouse effect isn't just a good thing. It's absolutely essential for life on Earth. It's the planet's natural climate control system. So if the greenhouse effect is natural and necessary, why does it have such a bad reputation? Why do we hear so much about it in the context of climate change? The problem isn't the greenhouse effect itself, but the enhancement of it by human activities. We've been adding extra greenhouse gases to the atmosphere, thickening that blanket around the Earth. Let's talk about the main culprit, carbon dioxide, or CO2. Since the Industrial Revolution began around 200 years ago, we've been burning massive amounts of fossil fuels, coal oil, and natural gas to power our homes, factories, and vehicles. Burning these fuels releases huge quantities of CO2 that were previously locked away deep underground for millions of years. At the same time, large-scale deforestation means there are fewer trees to absorb CO2 from the atmosphere through photosynthesis. It's a simple case of inputs and outputs. We're putting far more CO2 into the atmosphere than natural processes can remove. As a result, the concentration of CO2 in the atmosphere has risen dramatically. Pre-industrial levels were around 280 parts per million. Today, they've surpassed 420 parts per million. That's a massive increase in a geologically short amount of time. And it's not just CO2. Methane is another potent greenhouse gas. It's released from sources like agriculture, particularly livestock and rice paddies, as well as from landfills and the production of fossil fuels. While there's less methane in the atmosphere than CO2, it's much more effective at trapping heat, over 25 times more powerful, molecule for molecule. Over a 100-year period, nitrous oxide, mainly from fertilizers and industrial processes, is another powerful contributor. So, what happens when we add all these extra greenhouse gases? That atmospheric blanket gets thicker. More of the outgoing heat from the Earth's surface is trapped and re-radiated back down. The planet's energy balance is thrown off. More energy is coming in than is going out, and this extra energy results in a gradual warming of the entire climate system. This is what scientists call the enhanced greenhouse effect, and it's the primary driver of modern global warming and climate change. The consequences of this warming are far-reaching. We're seeing rising global temperatures, leading to more frequent and intense heat waves. The oceans are absorbing a lot of this extra heat, which contributes to sea level rise through thermal expansion. Water, expands as it warms. This warming also disrupts marine ecosystems, causing events like coral bleaching. Furthermore, a warmer atmosphere can hold more moisture, which leads to more extreme precipitation, events heavier rainfall, and flooding in some areas, while other regions experience more severe and prolonged droughts. Glaciers and ice sheets are melting at an unprecedented rate, further contributing to sea level rise and threatening the water supply for millions of people who depend on glacial meltwater. So, to recap the whole process, sunlight warms the Earth radiates heat back out, natural greenhouse gases in the atmosphere trap some of this heat, keeping our planet livable. This is the natural greenhouse effect. However, human activities, primarily burning fossil fuels, have released massive amounts of additional greenhouse gases, especially carbon dioxide. This thickens the atmospheric blanket, trapping too much heat. This is the enhanced greenhouse effect, which is causing global warming and driving the climate change we are witnessing today. Understanding the greenhouse effect is the first step towards understanding the larger issue of climate change. It's not a political debate, it's a matter of physics and chemistry. The science has been established for over a century. By grasping this fundamental mechanism, we can better appreciate why actions to reduce our greenhouse gas emissions are so critical for the health of our planet and the well-being of future generations. Thank you so much for joining me today to explore this crucial topic. I hope this explanation has made the greenhouse effect clear and understandable. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more deep dives into the science that shapes our world. And don't forget to hit that notification bell so you won't miss our next video. If you have any questions, drop them in the comments below. I love reading them and will do my best to answer. Thanks again for watching, and I'll see you in the next one.